Good morning, everyone. Now we'll start with this question and then we'll continue with the question that we left yesterday with. Okay. So a customer at a restaurant may order any combination of chips, salad, or onion rings. The probability that a customer chooses onion rings is 0.3. So this is a question that we talked about yesterday in terms of sets. So here we are saying probability of ordering an onion ring is 0.3 and probability of ordering a salad is 0.4 and chips and salad is 0.15. So when I say chips and salad, we are talking about C intersection S. Chips and salad will be 0.15. Then onion rings, chips and onion rings. So probability chips and onion rings is 0.15. Salad or onion rings is 0.55. So when I say or, salad or onion rings would be a union, 0.55. All three, that means it is chips and salad and onion rings, would be 0.05, and none would be either chips or salad or onion rings not, is going to be 0.2. Okay. So this is the given information. Identifying the given information is always going to be half of your sum, right? So if you identify the given information properly, then half of your sum is done. So the first part is we have to calculate the probability a customer chooses chips. Okay. The probability that the customer will choose chips. Okay. First of all, a few things. If I want to figure out the customer will choose chips, we want probability of chips, that is C. This is what we want. Okay. We can get that from the union of all three. Okay. So first of all, probability that I will get chips union salad union onion rings. Okay. So probability that I will get all one of these three. Okay, probability that I'll get one of these three would be 1 minus the complement. 1 minus probability chips union salad union onion rings complement. That would be 0.8. Now using that, we are going to make our formula. Using that, we are going to make our formula. So probability C union S union O is going to be probability C plus probability S plus probability O. We'll add each one of them, then we'll subtract union intersections. And then add the triple intersection. Now again, from the given information, what all do we have and what we don't? So we have PS, we have PO, we have C intersection S, we have C intersection O, and we have triple intersection. These values are directly given to us. We also have this now. Now we don't have the intersection between S and O, but we have the union. I can say probability S union O will be equal to probability of S plus probability of O minus probability of S intersection O. So using this, I will get so I have 0.15. So now we have this as well. We can substitute and get PC now. Right? We can substitute and get PC. PC is going to be this union minus these two, then plus these three, and then minus this. Okay. So first of all, union was 0.8 minus PS 0.4 minus 0.3, then plus 0.15 plus 0.15, then plus 0.15. All three were 0.15. I'll just check in the question. Yep, all three were 0.15, and then minus 0.05. Now I'll talk about the calculator in a minute. I'll just solve this first. So probability of chips is going to be 0.15. Next one is chips only. Probability of chips only. Now there are many ways you can solve this. But the easiest one is going to be figuring out which parts do we have to remove to get chips only. So let's draw a Venn diagram. Let's say this is chips. This is onion rings. And this is salad. When I say chips only is this part. Okay. Chips only is this part, right? So if I want to get this chips only part, what I'll have to do is I will have to take the chips and subtract what part? I will subtract chips intersection salad and subtract chips intersection onion ring. Okay. So from chips, if I subtract the intersection, I am going to get this region, but this part, that is the triple intersection part, has been subtracted 2 times. So I'll have to add it once. So plus chips intersection salad intersection onion ring. Any problem here? So I get 0.25. Any problem here? Let me know, please. Now, I'll talk about the calculator a little bit. If you're giving the examination from IFOA, that is the UK Institute, UK Institute, then the calculator that is recommended is Casio FX 991 ES Plus. If you're giving the examination from IAI, that is the India Institute, then the calculator that is recommended is Casio FX 82 ES Plus. Okay. Now 991 has slightly more, what do we say? Slightly more functionalities than the 82, but we require only the functionalities of 82 ES Plus. You will never be requiring more than that. Okay. So show the first part of the solution for a minute. Okay. So this is the first part. So the calculators are scientific calculators. So this is how the 82 ES Plus looks. Rather, the 991 also looks exactly same. I'll show you in a minute. And this is the old version. So this is the new version. This is the old version. You can get any one of them. It's not a problem. The only difference is the look. Okay, so if you have the old version, it's okay, no problem. This is the 82, and similarly 991. You can see 991 also looks exactly the same. This is the old version, only the color was different. Okay, so old version, new version, it does not matter which one you take. Okay, the functionality is exactly same. Now here, what I'll be doing is I'll be using an app to show you the functionality. By any chance, if you're downloading an app, see, in the examination, you need the physical calculator. It is always better to have the physical calculator. It's faster. Rather, here, I keep the physical calculator with me at all times because it is very much useful. Okay. But let's say in a pinch you want to use the app, so just download any scientific calculator. Just make sure that there are these 4 arrows in the middle, because we are going to use something called as navigation keys. Okay, that is part of your calculator to make the equations. So it's these 4 keys are going to be very important. Okay, so if you see the calculator, this lower part seems very similar. Simple buttons here. Del is to delete anything that you have written mistakenly. AC to clear everything. EXP, you will have 10 raised to here. So you can put 10 raised to. Okay, we'll talk about answer button and other stuff later. But if you see on top here, these buttons are extra. These are the scientific part of it. Okay. So if you want to make a fraction, you have fraction button here. If you want to make a root, you have here square. Any other power other than square, you can use this. You have log. This is log to the base 10. This is log to the base e. Okay. You have trigonometric functions. We will not be working with trigonometry, so we will not be using these. Okay. And you can see brackets here. Okay, so brackets can be used to make the equations. I'll just write down a simple equation. When we talk about a quadratic equation, let's say ax square plus bx plus c is equals to 0. In a quadratic equation, we say minus b plus minus under root b square minus 4ac upon 2a. This is the solution for this equation. Now let's take an example. I'll say 2x square plus 3x minus 4. I've just taken a random example. If I want to find roots of this, I can use this. Now I cannot do plus and minus together. Okay, I cannot do both plus and minus together. So what I'll be doing is one by one. First I'll use the minus. So I want to first create the fraction. So here we have the fraction button. I'll click that. Then minus b. So I'll have minus 3. I'll say minus. Now I want under root. Here's the under root button. I'll press under root and I can write it. Now you can see the cursor, red cursor is inside the root and we want it inside the root. So I'll say 3 square. I have the square button here. Then minus 4 into a is going to be 2 into minus 4. Okay. Now I want to go down in the equation. Now let's say even if let's say I had something here, let's say I had here into 5 or something like that. Okay, that is outside the square root. So to go to outside the square root, I would have pressed this side arrow key. Okay, so okay, the side arrow key is going to get me outside the square root. You can see here I am right now outside the square root and I would have multiplied by 5. You can see it is outside the square root, but I don't want to do that. This is not what we want. We want to go down. I'll press the down arrow key. This is the down arrow key here. I'll press that and I have 2 into 2 equal to. So one of the roots is going to be minus 2.35. This is one of the roots of this equation. Okay. Now if I want I just want to change that minus sign to plus sign. I don't want to write the whole equation again. So what I'll do is I'll press AC, but then I have these navigation keys. If I press up button or down button, it is going to see all the previous equations that I have used. So when I press up button, I get my equation back. If I go up again, it is the another equation that we have used. Okay, so up and down button can be used to navigate previous equations. You can see here. Okay, now I want to change this equation. I'll press now side arrow key. When I press side arrow key, I can edit this equation. I want to delete this minus and put a plus and I get another root 0.8508. So these will be the two roots of x. Okay, now Harshit, you are asking can we use MS version. Now see, in both of these calculator you can get an MS version, but I do not recommend the MS version because there are some functionalities in ES that we use that are not present in MS version. So I would recommend that you buy 82 ES plus. Okay, you may not have any problem in CS1, but you will definitely have problems later in CM1, in CM2, because of those functionalities that we require are part of ES but not part of MS. Okay, so do not buy the MS version, buy the ES version. Okay, very important. So this is how we can use this extra functionality. We can make very elaborate equations. Okay, I have an official meeting now, so I am leaving. Hope, yeah, no problem. You can now. Okay, one more thing before you leave. Okay, now I've decided, I've got feedback from a few students that weekend is not very much possible. So what we can do is we can have our batch weekday in the evening. Okay, so by the evening I think everybody is going to be free. So what I'm planning is Tuesday and Thursday. We'll have 6 to 8 p.m. Okay. So evening would be easy for, I think, everybody, right? So this is the recommended time. If you have any other problems, let me know. We can change weekdays. If somebody else has, other classes or something, we can change. Okay. So we'll talk about this later as well. Let's talk about the calculator. Okay. So Mustafizir, you can leave right now, no problem. Okay, so this is how we use a scientific calculator. Now you can see there are many other functionalities. If you want to make an equation using log, so this log is log to the base 10, this ln is log to the base e. Okay, you can use brackets to make equations and stuff. Okay, so let's say if I have a complicated equation like I have log, this is log to the base 10, let's say. Let's say this is the equation that I want to make. Okay. So first, log to the base 10 is going to be this log, right? Log to the base 10. Then to raised to bracket, raised to this box. Now I can write there 3.5 plus 2. So I can make the equation inside that box. It should not just be one single value when I'm talking about the power. Okay. Now you can see the cursor is in the power. I have to get it down. So I will use the navigation key is to get it down, and then minus 4. I'll close the bracket. So close bracket here, and then minus. I need another bracket open. I'll open the bracket. 5 plus 3 square. I have directly button for square. I'll just use square. Bracket close and equal to. So this is the answer, minus 12.384. So we can make a very elaborate equation when it comes to our scientific calculator. Okay. Now the other thing, you will see that other than the buttons, there are many things written in yellow. You can see on top of the buttons, and also some buttons they have written something in purple. So these things you can access using shift and alpha button. Okay. So if I want to access anything written in yellow, I will press the shift button first. And if I want to access anything written in purple, I'll press the alpha button first. Like in this calculator, we can directly do permutation and combination values. So like when we talk about combination, let's say I'm talking about 10C5. 10C5 is going to be 10 factorial upon 5 factorial, 10 minus 5 factorial, that is basically 5 factorial again. So I can use factorials to find this value. You can say fraction, and then if you see the factorial, it is just above x raised to minus 1. You can see here we have factorial. So I can say 10 shift, and I press this x raised to minus 1, I get a factorial. Again, I go down, I want 5, shift, and then factorial into 5, shift, factorial. Okay. So I use shift to make this factorial, and the answer is 252. I can also Okay, Apurva, you are saying I'm a working professional, so I can attend on weekends only. Can I opt for your recorded lectures? Yes, you can opt for recorded lectures. The recording will be of, see, it is of online batch, similar to what we are studying right now. Okay, so, and if you have any problem, you will get my number directly from the office and you can contact me whenever you feel like. Okay, so recorded lectures, you will not have any problem. It's not a special recording, it is basically the class recording itself. Okay. Now this 10C5 we can directly create. Okay, so we have, if you see down here, division and multiplication. Above that we have NPR and NCR written, that is permutation and combination. So for this I can say 10, shift, and then press the division button. Press the division button, I get a C, that is for combination, and 5 equal to. So this is 10C5. 10C5 is 252, right? So this is how we create or use the shift and the alpha button. Okay, so there are a lot of functions that we are going to go through throughout this course. I will be teaching you one by one. So even if you have never used a scientific calculator, you don't have to worry about it. We'll be using scientific calculator throughout. Okay, please buy the recommended calculator. Okay, and there is no actual restriction in IFOA for the calculator, but this is the best calculator that we can go with, and it's just easier. It contains all the functionalities that we would want, and most of the colleges recommend this calculator itself. Okay, so if you are studying in a college and require a scientific calculator, this is the calculator you might be already using. Now, remember the question that we left with yesterday. Where's the question? Yeah. This is the question that we left with yesterday. Okay. So we had 4 cards are randomly, or let me just paste it here. So 4 cards are randomly chosen from a deck of 52 cards. Find the probability that all 4 are aces if first we said all cards are replaced after selection. And we said if we are talking about replacement, then they are independent events, and that is why the probability of all 4 being aces is same as probability that we get ace individually in all 4 events. So we got 1 by 13 raised to 4. I can just calculate in decimal places. So bracket 1 by 13 raised to 4. Okay. So it is 0.000035. Now one more thing, there is a button called SD. You can see here there is a button above delete, SD. This button is used to convert your answer from decimal to fraction. Now you can see I clicked it and it went to fraction. I can click it again, it will go to decimal. So it converts your answer from decimal to fraction or fraction to decimal. Okay. Now the second part. Now when we say that there is no replacement possible. Okay, so we are selecting 4 cards randomly and there is no replacement of cards. Now there are 2 main methods of solving these type of sums when replacement is not possible. First I'll show you the longer method, then I'll show you the smaller method. The first method is called as a tree diagram. Tree diagram is useful if you are trying to figure out all possible outcomes. Okay, so in all possible outcomes, I'll say in the first card I can choose either a ace or not a ace. I will use A for ace and I will use N for not a ace. Okay, so I'll say for the first card I can choose ace or I can choose not a ace. Okay, these are the two possibilities. Then for the second card I can again get an ace or not an ace. Now this can happen for both the possibilities. I can get an ace or not an ace. Then in the third card again I can get ace or not an ace. Similarly here. And same thing with the fourth card. I can get ace or not an ace. So we are sort of making tree with all the branches. These are all possible outcomes when I'm talking about 4 cards. So this is the first card outcome. This is the second card. This is the third card. This is the fourth card. These are all possible outcomes of these 4 cards. Okay. So we are saying in the first card I can get ace or I can get not an ace. Okay. Now let's talk about what is the probability of that happening. In the first card I had total 52 cards and in that I had 4 aces. Right. So the probability that I will get an ace is 4 by 52. Right. And probability of not getting an ace. So that would be 48 by 52. It is just 1 minus of 4 by 52. I'm not going to simplify this. Okay, we'll do the simplification at the end only. Now, after getting an ace in the first card, what is the probability that I will get another ace? After getting an ace, what is the probability that I will get another ace? Now, after my first card has been chosen and I'm not replacing it back into the deck. Now, in total, I have only 51 cards. I have only 51 cards, out of which there are only 3 aces now. Out of those 51 cards, because I have already got an ace, there are only 51 cards in total and 3 aces inside it. So 3 by 51. And in such case, when I have got an ace, there are still 48 not aces. N would be not aces. So I still have 48 out of 51 chance of getting not an ace. So you can see how these are not independent of each other. What I'm getting in the first card is affecting the probability of the second card. These are not independent of each other. Right? Similarly, if I got any card other than ace in my first selection, if I got any card other than ace in my first selection, what is the probability that I will get ace in the second selection? So I still have 4 aces in the deck, but I have 51 cards left. So probability here becomes 4 by 51. And probability of getting not an ace. So I only have 57 not aces right now. So 47 not aces in the deck because one has already been chosen in card 1. So 47 by 51. Now this is how you are supposed to go for each one of these branches. Now we don't want all the branches. We just want the branch that has 4 aces. We just want ace, 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 ace. This is the branch that we want, where we get all 4 aces. Okay. So I will not complete the whole probabilities of each one of those branches. What I will do is I will just complete the probabilities here, okay, of this branch. Now when we come up to this branch, what are we talking about? We are saying that we already got 2 aces. We already got 2 aces. Now what is the probability of getting a third ace? So in the deck I am left with only 2 aces and 2 cards are already out, so I have 50 cards in total. So 2 by 50. If I'm talking about this, I don't need this, but let's talk about it. If I already have 2 aces out, total cards are 50, but total non-ace cards are 48. You can do this for each one of these. I'll do these two just so that we understand what's going on. If I am at this point, I'm saying I have got an ace, I've got any card that is not an ace. Okay. First card I got an ace, second card I got n, not an ace. So here, when I am talking about this deck, I have total 50 cards. So upon 50, out of which 1 ace is gone. So I'm left with only 3 aces. Similarly here, total cards are 50, and out of which 1 not ace is gone. So I'm left with 47 of them. This is how you can count and fill all of these tree diagram. But as I said, I need only one of them, that is this part. I'm left with only this part. Okay. So here I already have 3 aces out. So in the deck I am left with only 1 ace out of 49 cards. As I said, we can fill all of them. Now what are the possibilities that I am getting here? Okay. So what am I getting? This is, I'll write it here. This one is giving me 4 aces. This is what am I getting. This branch is giving me ace, ace, you can see here. Okay, ace, 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 and then not an ace. This branch you can fill the whole one. You can figure out what are the possible values. So if I ask you what is the probability of getting all 4 aces, that is what was asked here. So I will look at the branch that is giving me all 4 aces. This is the branch that is giving me all 4 aces. And I will just multiply the probabilities. So I'll say probability of getting all 4 aces would be, just multiply. So I will have 4 by 52 into 3 by 51, 2 by 50 into 1 by 49. Okay. By any chance, if I was asked what is the probability that I will get ace, ace, not an ace, and another ace. if that is what we wanted, the branch that I will get ace ace, then not an ace, and then another ace. This is the branch that we would have wanted. I would have just multiplied all 4 probabilities of that branch. If I am looking for probability of, let's say, ace, not an ace, then ace, and then not an ace. Okay. In that case, we'll say ace, not an ace, ace, and then not an ace. This is the branch that we are talking about. So if we write the probabilities on each branches, we can get probability for each of those permutations. Okay. So if I'm talking about one of these branch, this is one permutation. Okay. One permutation. Permutation means all possible arrangements. Okay. So these are going to be all possible arrangements. If you start writing each one of them, you will get all possible arrangements that I can get with this situation. And I can get probability of each one of those arrangements. Now, of course, we wanted only one. We wanted ace, 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 ace. Now, to solve this, you have an easier way. What we can do is, we can say, that out of 4 aces, I will choose any 4 upon out of 52 cards, I am choosing any 4. You can use the combinations to find the answers here. Okay. You can use combinations. Show you this 4 into 3 into 2 into 1 upon 52 into 51. Okay. Or I can use combinations. I can say 4 C 4 upon 52 C 4. You can see it's the same answer. So either you can use the tree diagram, and of course tree diagram is much more lengthy, or you can use combination. So I prefer using combinations, just much faster. Now let's say in this part I asked you to calculate probability of getting 2 ace and 2 other cards. Okay. So I'm talking about getting probability of 2 aces and 2 other cards. Okay. Now I'm not specifying in what arrangement do I want them. So I can have ace ace, not not. I can have ace not, ace not. I can have ace not not, ace. I can have not ace, not ace, not not, ace ace. I think these are all the possible outcomes that we can get from these positions. Okay. So I'm saying I want probability of each one of them. Okay. So if I'm using tree diagram, what I will do is I will add up all of such positions. Okay. What are those positions? I want ace not, not ace. Okay, first of all, This is the first one. This is the first one. This is the second one. I think this is going to be the third one. I'll have A, N, N, A. This is the third one. Then here I have N, A, N. This is N, A, N, A. I'll have N, N, A. These are the 6 permutations. So you can find probability of each one of them from their branches and then add them up. And you can add them up to get the probability of this. Or what you can do is, if you want probability that I want 2 aces, 2 N's, for that you will say out of 4 aces I want to select any 2. Out of 48 non-aces I want to select any 2, upon in total I had 52 cards, out of which I am selecting any 4. This is the easier way. If you are choosing combinations, we will use combinations to find the values, find the probability. Okay. And simply I'll say 4 shift C2 into 48 C2 upon 52 C4. Out of 52 I want any 4. So do we understand what's going on? If we do not have independent events, then we are going to use combinations to find the questions or find the answers. Okay. If you want a single permutation, then tree diagram would be fine. But if you want multiple permutations, like here we wanted 6 of them, it's not convenient for us to make the tree diagram for everything and then answer accordingly, because you can see it's very lengthy. Tree diagram already very lengthy. Then finding each one of those probabilities is much more lengthy. Finding using combinations would be much simpler. I'll give you another question. Let's just find question in the book. It's just easier, quicker. Okay, I think they have directly given conditional independent. Yeah. So this is the question. Prita, you're asking that is this part of CS1 syllabus or it's a prerequisite? It's a prerequisite class. These are, even though I'm saying these are not going to be asked in the examination, but these are very important topics. These are very important basic chapters, because this makes up the basis of all of the statistics that you are going to study, not only in CS1 but later on in CS2 and later subjects as well. Okay, so these are very important. Understanding probability is very important. How we find the independence and non-independence, these are going to be important things. Okay, so even though they won't ask you a direct question of this chapter, but that does not mean it's not an important chapter. Okay, so this question: a box of chocolates contains 8 milk chocolates and 4 plain chocolates. A chocoholic eats 3 chocolates. Calculate the probability that all 3 are milk and 2, exactly 1, is a plain chocolate. Okay, so first part, all 3 are milk. Now first of all, we'll decide whether we are selecting 3 chocolates. So we have to decide whether these are independent selections or whether these are dependent selections. Can you tell me whether this is independent or not? They have not written whether they are replacing the chocolates or not. Correct. But they clearly said we have 8 milk chocolates and we have 4 plain chocolates. Right? If a person eats one, let's say I eat 1 milk chocolate. Now there are only 7 milk chocolates. I cannot replace it with another. So clearly this is without replacement. That means these are not independent events. Okay, these are not independent events. Okay, because we cannot replace those chocolates after eating it. Okay, so when we are talking about probability of getting all 3 milk chocolates, 3 milk chocolates. Okay, so that is going to be, out of 8 milk chocolates I will choose any 3, upon out of total 12 chocolates I am choosing any 3. We'll just use combinations. Okay, now when it comes to non-living things, like we were talking about cards before, right? So whenever we are talking about non-living things, usually we have to mention whether we are replacing it or whether we are not replacing it. Okay, because there is a possibility of replacement. Here they clearly said 8 all 3 chocolates. So we had no option of replacing it. Okay, so that is why we did not have a mention of whether there is a replacement, whether there is not a replacement. But when it comes to selecting teams out of living people, so whenever you have an example of living animals or living people, you will find that replacement is not possible. If I say selecting a team of 11 cricketers out of 20 players, when I select the first player, I cannot put him back into the line and say I'm selecting that person again. It's not possible. So replacement is not possible there. So there we clearly do not have any replacement. For non-living items, you will have to figure out whether replacement is possible or not. Usually they give it, okay, in the question. Here clearly replacement was not possible. Let's say 8 C3 1 12 C3. Second part, exactly 1 plain chocolate. So we are talking about 2 milk and 1 plain. Again, they did not say that whether it should be plain milk or milk plain milk, or whether it is milk plain. They did not talk about the arrangement of how we selected that chocolate. They're just saying we want one plain chocolate and two milk chocolate. So we'll directly use combination because we are talking about all three combinations. So out of 8 milk chocolates, I am choosing 2. And out of 4 plain chocolates, I am choosing 1. Out of 12 total chocolates, I am selecting 3. So 8C2, 4C1 is just going to be 4 upon 12C3. So this is how using combinations we can solve all of these sums. By any chance, if they were talking about any permutation, let's say they specifically said that the person ate a milk chocolate, then a plain chocolate, and then a milk chocolate. Okay. So if I'm talking about only one specific permutation, what we can do is we can easily figure out how many items were remaining at what point. Okay. So for this first selection of milk chocolate, I had 8 milk chocolates available. I chose one of them. For the second selection, I had 4 plain chocolates available, out of which I selected one. Then for the third selection, I had only 7 milk chocolates available, out of which I chose one. Right? I chose milk, plain, and then milk. So for the first milk chocolate, I had 8 available. For the second selection of milk chocolate, I had only 7 available because I have already ate one. For plain, I had all 4 available here. Okay. And now I will choose the denominators. For the first chocolate, I had all 12 available chocolates. For the second one, I had only 11 chocolates available. For the third one, I had only 10 chocolates available. So if I am choosing only one permutation, what I will do is I will just say it is 8 by 12 into 4 by 11 into 7 by 10. So this is for combination, this is for a permutation. So you can see the difference. Okay, this is just one single permutation. Now because we had 3 permutations possible, we had MMP and PMM. You will find all 3 have exactly the same probability, and that is why this is exactly this much divided by 3. You can try that and you will find that it is exactly the same because all of these 3 permutations will have exactly the same probability. You can try that. So if you have single permutation, just figure out how much availability we had at what point. And if we have combinations, use combinations. Any problem here? Now, if you have not studied permutation and combination before, it might be a little bit difficult to understand what's going on. But I have made videos of permutation combination also. We'll give you that later on. So by any chance, if you have a problem, you have not studied permutation combination, you have the office number below. Just message us, WhatsApp or Instagram. Sorry, not Instagram, WhatsApp or Telegram, right? Whichever method you prefer, WhatsApp or Telegram on that number below, and we'll send you the permutation and combination videos. And if you have still problems, you can ask me later. Okay. Now, before we go further, I just want to clarify that our classes is going to be Tuesday and Thursday, 6 to 8 p.m. Okay. It will be online. We will be conducting through Google Meet itself, like we are doing right now, but the link will change. Okay. So now, if you register today, okay, if you register today with us by paying 10% of the fees. Okay, we talked about fees yesterday. I don't remember whether we talked or not. I'll just show you the fees structure. Okay, so here we have the fee structure. Okay, so for CS1, online and offline batch is 23,000. The offline batch is going to be in the weekend. So by any chance, if you live in Mumbai and you can attend the offline batch, you can attend the weekend batch as well. But the online batch is going to be during the weekday. Okay. If you want to go for the recording of the previous year's, recorded lectures, online lectures, it's 17,000. Okay. And if you are going to register with us by paying 10% of the fees today itself, okay, if you pay 10% of the fees today itself, you will get 10% discount on the fees. Okay, so we'll give you discount over this 23,000. So you will get a discount of 2,300 rupees, okay, on the fees. So if you register today itself, then you can definitely pay the whole fees, no problem. But even if you pay 10% and register with us, that will not be a problem. And admission cancellation is allowed till 1st May. So you can cancel your admission within those 10 days as well. Okay. So that is also possible. Okay. Any other question, or should we continue? If you have any other question, you can ask me. So let's move to conditional probability. First, I'll talk about it mathematically, then we'll talk about what's going on. Okay, so mathematically, this is how we write the conditional probability. We'll say it is probability A given B. Okay, we call it as A given B. Okay. Now this means that B has already occurred. What is the probability that A will occur? Okay, so we are saying B has already occurred. What is the probability that A will occur? Okay, so there is some given information according to which we are trying to calculate the probability of something else. Okay, a simple example, let's say out of the 52 cards, I have selected one card. I see and I tell you that it is a club. Now, what is the probability that it will also be 7? So, I've given you the information that one card is selected and that card is club. Now, can you tell me what's the probability that it will be 7? Anyone? I've told you that it's a club. What's the probability that it will be a 7? Come on, it's very simple. How many clubs are there? There are 13 clubs. And out of those 13 clubs, how many are 7s? Only one is a 7. Right? So, if I told you the card is a club, I have already told you that the card is a club, then there are only 13 options. And out of that, only one is going to be a 7. So, what we are looking for is 1 by 13. Right? Now, when I say picking a 7, picking a club, probability of A was 4 by 52. Probability of B was 13 by 52. And probability of A intersection B was 1 by 52, right? So probability of A given B, that means probability that I will pick a 7 given the card was club. Okay, given that the card was club, then so it is probability of A intersection B upon probability of B. So even logically we said the probability should be 1 by 13, and mathematically also we are getting the probability is 1 by 13. So when there is something given, there is a given information and we are finding probability of something else, we use conditional probability. Okay, we use conditional probability. Let's take another example. This is, let's do this example. In a group of 24 actuaries, 20 have worked for a life office A and 12 have worked for life office B. Everyone in the group has worked for at least one of the two companies. When they say at least, that means it could be both the companies as well. What is the probability that the actuary picked at random has worked for? Okay, first of all, the given information, life office A, 20 have worked. Life office B, 12 have worked out of 24, out of 24. And everyone in the group has worked for at least one of these companies. So I'll say probability that A union B, that means either A or B or both, would be 1, because everybody has worked for either A or B or both. So first is probability that a randomly picked actuary works for life office A and life office B. So I want probability intersection. I want intersection. So this is going to be 8 by 24, I think. And you can simplify it 1 by 3. Okay. Second part, life office A, given that they have worked for life office B. So we want probability of working in life office A given that they have worked in life office B. So that would be A intersection B upon probability of B. Now see, this is the reason I prefer not to simplify at the beginning. You can see it would be easier if I had the answer as 8 by 24. 24 cancels out and I will get 8 by 12 and then I can simplify it and say it is 2 by 3. Now you can write it in decimals also if you want. 1 by 3 would be 0.333 and 2 by 3 would be 6667. Right. This is how conditional probability works. Probability that we have certain information and what is the probability of getting something else. That's called conditional probability. Any problem here? Now you might have noticed that for answers writing in decimals, I am using sometimes 6 decimal points, sometimes I am using 4 decimal points. Now there is a logic behind it. Okay, we say we are not worried about the decimal points, we use significant numbers. What's a significant number? Now a significant number is the digits that give value to a number. So that means, okay, Pritha, you're asking why is probability A union B 1? Okay, why is probability A union B 1? So in the question they said that everyone in the group has worked for at least one of the two companies. Okay, so when I say everyone in the group has worked for, that means all of these 24 actuaries have worked for either A or B or both. So when I say either or, I'm talking about union. So I'm saying all 24 of them are part of this either A or B. So 24 by 24, that is 1. Right? Okay. And remember, probability will always be between 0 and 1. It will never be less than 0. That means it can never be negative, and it will never be more than 1. So probability, maximum the probability is going to be 1. Okay. Minimum it is going to be 0. So let's get back to significant numbers. So let's say if I have 0.001204. In this, the significant numbers are 1, 2, 0, 4. The zeros before and zeros after will not count. That means if I have 1, 2, 0, 4, 0, 0, 0, 0, these zeros do not count as significant numbers. I still have only 4 significant numbers. Okay. So anything, I will write this as 1.204 into 10 raised to minus 3, and this I will write 1.204 into 10 raised to 5 and 8. So this 1204 are called as significant numbers. This 10 raised to part are not part of significant numbers. So the digits that give value to any number are called as significant numbers. Okay. So for calculation purposes, we use at least 6 significant numbers. And for answers, we use at least 4 significant numbers. That is how we that is how we make sure that we are not making any mistakes, approximation mistakes, right? This is very important. So now anything else you would like to ask me? Tuesday and Thursday 6 to 8, and we are talking about discount if you are going to register today. If you want to ask me anything related to how we are going to study, what we are going to study, we can clarify that. Okay. So we have the 3 basic chapters. The 3 basic chapters we will study from a different book. Okay. And then these are the part of our course. Okay. Analysis part we'll be studying from a different book. Okay. So we'll provide you with the books. We'll provide you we'll provide you with the books, assignments. We'll provide you with regular test. So we have tests designed chapter wise, we have tests designed section wise, and we have tests designed as mock test after we have completed the whole course. Okay, Tejas here asking if we take up recorded lectures, can we join the class occasionally to clear the doubts? Yes. So even if you take recorded lectures, there are multiple options. If you have small doubts, you can directly ask me. You will get my number. Okay. So you can directly ask me on WhatsApp, or we can conduct a call. If you have conceptual doubts on certain topic you would like to revisit, you can join the online lectures. That will not be a problem. Okay. And even for the recorded lectures, for the last 1.5 months, we have live doubt sessions. So because for the last 1.5 months, we expect that you are going to you must have completed the course, and now if there are any doubts, you can ask me in live lectures as well. Okay. So we have regular tests, we have mock tests. So these are all the materials that we are going to give you. Okay, assignments are nothing but chapter wise questions from previously asked examinations. Okay, so the questions will be very similar to how they ask in the examinations. You will not have any problem. You will get a practice of the exam itself. Then we have mock test for that, so that you get practice of examination before the examination. We complete our course at least 1 month before the examination. At least 1 month before the examination we are complete with our course, and then regularly you will have doubt sessions, you will regularly have tests, and we'll solve those tests or difficult questions in the doubt sessions as well, so that by the time of the examination you are very well prepared for the examination. Not only the knowledge but also for the examination you are well prepared. Yes, along with recorded lecture also you will get exactly the same things. Okay, there is no difference between recorded lecture and live lecture. Whatever we provide in recorded lecture and what we provide in live lectures, you will not have any difference. Okay, because those are also basically live lectures of previous sessions, right? So you'll not have problem even if you take recorded lectures. Now see, the biggest difference in recorded lecture and live lecture is that you have a regular schedule. Okay, so when we are talking about live lectures, you have a regular schedule, you follow that schedule. If you are talking about recorded lectures, we'll give you all the lectures together. One day you will watch 3 hours of lecture, the other day you will say okay, I'll do it tomorrow, right? This is what happens. So if you are sure that you don't have a problem of procrastinating your studies, then you are okay with recorded lectures. But if you feel like one thing is, some people say that they don't understand just by using recorded lectures. In live lectures you can immediately ask me, sir, please explain again. So I try to explain in a different way. That is one advantage. And the second is, you are following a regular schedule. Every time I will say okay, now solve this assignment, okay, next time we'll discuss this assignment. So you tend to go home and solve the assignment, right? So what happens is, you have a regular schedule. But in recorded lectures, people sometimes fall behind, but some people are very good at following a schedule, then it is well and good. If you can make a schedule and follow it yourself, you can definitely go for the recorded lectures. Okay, and you will not find any difference in recorded lectures or live classes in terms of teaching or material. Okay, anything else? If not, I hope yeah.
So one question, Anup here.
Yes.
So for the material, will it be soft copies or hard one?
We see, if you are in Mumbai, we can print out those material for you. We'll provide you soft copies of everything and you can print it out yourself. Okay, so for assignments I would definitely recommend you print it out. For book, not so much. You can refer the book on your mobile phone, you can refer the book on your computer. Okay, for assignments it's always recommended you print it out. Okay.
Sure. Yes.
So any other question? So if there is no question, we can end the class here. You have the contact number below. You can contact at any time and Deepak sir will help you out in any form of queries. Okay, and we can meet Tuesday. Okay, next Tuesday we'll have a regular lecture. Okay, so bye.